There is a plant growing wild in American farmlands that contains more protein than corn, wheat, and rice combined. It thrives where other crops die. It feeds entire populations with complete nutrition. And for nearly 5 centuries, it has been banned, burned, and branded as enemy number 1. Not because it fails to feed people, but because it succeeds too well. This plant once sustained the mighty Aztec Empire. It built civilizations. It survived conquistadors, famines, and industrial agriculture's chemical warfare. Today, scientists call it a superweed. Farmers spend billions trying to destroy it, but hidden in those twisted stems and stubborn roots lies the key to feeding a hungry planet. Welcome to the story of amaranth, the plant that refuses to surrender. In the laboratories of NASA, researchers discovered something impossible: a single plant species that could revolutionize space farming, end malnutrition, and produce more protein per acre than any grain on Earth. The same plant that agricultural departments classify as public enemy number 1. The same plant that costs American farmers $33 billion annually in crop losses. This is not about weeds versus crops. This is about a 500-year war between control and abundance, between systems that demand permission and plants that grow without asking. Before European ships crossed the Atlantic, before corn became king, before soybeans conquered the Midwest, there was huatli. The Aztecs called it the grain of the gods. They shaped it into sacred figures with honey. They offered it in temples that touched the sky. They fed armies that conquered nations. Amaranth was not just food, it was power itself. Then came 1519. Hernán Cortés landed with steel, gunpowder, and a mission to break more than just military resistance. He understood what modern agribusiness knows today: control the food, control the people. The Spanish did not just ban amaranth cultivation, they made growing it punishable by death. Fields were torched, seeds destroyed, hands were severed for the crime of planting. For 4 centuries, amaranth vanished from the mainstream. But plants that survive extinction do not disappear quietly. In hidden valleys of Mexico, in remote mountain villages, indigenous families passed down seeds like precious heirlooms. Grandmothers whispered growing instructions to granddaughters. The grain of the gods survived in secret gardens, waiting. The 1970s brought rediscovery. NASA scientists searching for crops that could grow in space stations stumbled upon something extraordinary in those ancient seeds: complete protein containing all 9 essential amino acids, iron levels that shame spinach, calcium content that rivals milk, a biological value of 75, matching the nutritional efficiency of animal proteins. The numbers seemed impossible. Amaranth grain contains 16% protein. Corn manages 9%. Rice delivers 7. Wheat barely reaches 14. But amaranth does not just deliver quantity. It delivers quality that food scientists called revolutionary. The protein digestibility score hit 90%. Soybeans, the supposed protein champion, scored only 78. Researchers in Guatemala tested amaranth against every plant-based protein source they could find. Nothing came close. This was not just another grain. This was a complete food system disguised as a weed. The leaves proved even more remarkable. Vitamin C content that dwarfs oranges, iron levels exceeding those found in red meat, beta-carotene concentrations that make carrots look inadequate, calcium, folic acid, and protein density that transform simple leaves into nutritional powerhouses. Educational concerns for hunger organization documented what ancient peoples knew instinctively. Amaranth leaves and grains together provide everything the human body needs to thrive. Complete nutrition from a single plant species that asks for nothing but sunlight and rain. Modern food scientists confirmed the impossible. Amaranth contains lunacin, a peptide with anti-inflammatory and cancer-preventive properties. It delivers magnesium and phosphorus in concentrations that qualify as excellent sources by nutritional standards. The grain provides fiber, iron, selenium, and vitamin B6 in amounts that address multiple dietary deficiencies simultaneously. This is not health food marketing. This is biological reality verified by decades of research. Yet something went wrong. Terribly wrong. The same plant that NASA wanted for space missions became the nightmare of American agriculture. The grain of the gods transformed into Palmer amaranth, the superweed that destroys crops and bankrupts farmers. Palmer amaranth grows 3 inches per day. It reaches heights of 8 feet. It produces up to 500,000 seeds per plant. Each seed remains viable in soil for decades. The plant germinates from March through October, giving it growing seasons that outlast every crop designed to compete with it. But size and reproduction rate were not the real problems. The crisis began when industrial agriculture declared chemical war on everything that grew without permission. Glyphosate, marketed as Roundup, promised to solve the weed problem forever. Monsanto engineered corn, soybeans, and cotton to resist the herbicide. Farmers could spray entire fields, killing everything except their genetically modified crops. The plan worked perfectly until Palmer amaranth fought back. Within years, populations developed complete resistance to glyphosate. The chemical that was supposed to control weeds became useless against the very plant it was designed to eliminate. Evolution accelerated. Palmer amaranth developed resistance to multiple herbicide classes simultaneously. 6-way resistance emerged in Kansas populations that survived every chemical weapon in the agricultural arsenal. ALS inhibitors, photosystem inhibitors, EPSPS inhibitors, mitosis inhibitors, carotenoid biosynthesis inhibitors, and more. Nothing worked. The implications staggered agricultural researchers. A single Palmer amaranth population in Kansas showed 28 to 100% survival rates against field-recommended doses of every major herbicide class. This was not gradual adaptation. This was biological warfare won by the plant. Synthetic biology techniques applied to eliminate a plant that could solve global hunger. The absurdity compounds when you examine what Palmer amaranth actually does to farmland. It does not deplete soil like corn monocultures. It does not require irrigation like soybeans. It does not need fertilizers, pesticides, or genetic modification. Palmer amaranth improves soil structure with deep taproots that break compaction. It prevents erosion with extensive root systems. It provides habitat for beneficial insects. The plant classified as agricultural enemy, number 1 performs better ecological services than the crops it supposedly threatens. Meanwhile, half the world continues eating amaranth without calling it a superweed. In India, they grow it as Rajgira. In China, it appears in traditional medicine and cuisine. Across Mexico, vendors sell amaranth candy in markets where conquistadors once burned fields. Indigenous communities from Peru to Guatemala never stopped cultivating the grain their ancestors called sacred. These populations do not struggle with Palmer amaranth infestations because they never declared war on amaranth in the first place. They grow it intentionally, harvest it systematically, and eat it regularly. The superweed problem exists only where industrial agriculture treats amaranth as an enemy rather than an ally. The resistance crisis forcing American farmers toward bankruptcy could disappear overnight with a simple shift in perspective. Instead of spending billions trying to kill amaranth, what if we spent millions learning to harvest it? Instead of engineering new herbicides, what if we engineered new food systems that include the most nutritious grain on Earth? NASA understood this decades ago. Their research on amaranth productivity under stress conditions proved that Amaranthus cruentus thrives in environments that kill conventional crops. Extreme heat, drought, poor soils, high salinity. Conditions that define much of our planet and most of space. The same traits that make Palmer amaranth a superweed make amaranth a superfood capable of growing where nothing else survives. Climate change predictions show expanding regions where traditional crops will fail. Rising temperatures, unpredictable rainfall, degraded soils. These are precisely the conditions where amaranth excels. Food security experts warn that feeding 9 billion people requires crops that produce more nutrition per acre while using fewer resources. Amaranth delivers exactly that. 16% protein content using half the water corn requires. Complete amino acid profiles without synthetic fertilizers. Yields that increase under stress rather than decrease. Yet agricultural policy continues treating amaranth as a problem requiring solutions rather than a solution requiring implementation. The conspiracy extends beyond farming into food systems designed around corporate control. Amaranth cannot be patented. You cannot create sterile hybrid varieties that force farmers to buy new seeds annually. The plant reproduces freely, spreads naturally, and grows without industrial inputs. Every trait that makes amaranth nutritionally and environmentally superior also makes it economically threatening to agribusiness models built on dependency. Corn requires specialized equipment, chemical inputs, and corporate seeds. Amaranth requires soil and sunlight. Soybeans need herbicides, fertilizers, and processing facilities. Amaranth can be eaten raw, cooked like rice, or ground into flour using simple tools. The grain that sustained civilizations for thousands of years threatens business models that profit from complexity, dependency, and scarcity. Industrial agriculture cannot monetize plants that grow without permission and feed people without processing. This explains why Palmer amaranth resistance research focuses exclusively on elimination rather than utilization. Why agricultural extension programs publish eradication guides instead of cultivation manuals. Why farmers receive subsidies for growing commodity crops that require chemical inputs but face regulatory barriers for growing amaranth that needs nothing. The system is working exactly as designed, not to feed people efficiently, but to generate revenue consistently. Mexico recently designated amaranth a strategic resource in their national crusade against hunger. The government that once banned amaranth cultivation now promotes it as essential for food security. The same plant, the same nutritional profile. The only difference is political will to embrace abundance rather than enforce scarcity. Indigenous communities across Latin America never needed government permission to recognize amaranth's value. They preserved seeds through centuries of suppression, maintaining genetic diversity that modern plant breeders are only beginning to understand. Varieties adapted to specific climates, altitudes, and growing conditions. Living libraries of agricultural wisdom encoded in seeds passed between generations. This knowledge remains largely inaccessible to industrial agriculture because it cannot be owned, patented, or controlled. Traditional varieties belong to communities, not corporations. Growing techniques developed over millennia require understanding local ecosystems rather than applying universal inputs. Palmer amaranth represents the collision between these two approaches. Industrial agriculture demands control over every variable. Amaranth embodies biological systems that resist control while delivering superior results. The conflict was inevitable. The resolution requires abandoning the illusion of control in favor of working with natural systems instead of against them. This means designing food systems that celebrate amaranth's vigorous growth rather than penalizing it. Developing markets that reward nutritional density rather than just commodity volume. Creating policies that support biodiversity rather than monoculture dependence. The technology already exists. The nutrition is proven, the environmental benefits are documented, the economic potential is enormous. The only barrier is institutional resistance to plants that succeed without permission. The superweed that terrifies industrial agriculture could become the superfood that saves it, but only if we stop trying to control amaranth and start learning to partner with it. Amaranth teaches us that abundance and control cannot coexist. For 500 years, we have chosen control. We banned the grain of the gods, declared war on superweeds, and spent billions fighting a plant that could feed the world. The result is resistance, bankruptcy, and a food system that depends on scarcity to generate profit. But the choice remains ours. Every Palmer amaranth seed contains the same nutrition that sustained the Aztec Empire. Every superweed invasion offers the opportunity to harvest protein instead of spraying poison. Every resistant population proves that nature refuses to surrender to systems built on suppression. Climate change is coming. Traditional crops will fail. Industrial agriculture will collapse under its own contradictions. When that happens, amaranth will be waiting. The same plant growing wild in farmlands today, ready to feed whoever has the wisdom to recognize abundance disguised as a weed. The Aztecs called it huatli, the grain of the gods. NASA calls it a space crop. Farmers call it a superweed. Indigenous grandmothers call it survival itself. The name changes, the plant remains. 16% protein, complete amino acids, and the stubborn refusal to ask permission before feeding people. The war is over. Amaranth won. The question now is whether we will continue fighting or finally learn to feast.